Hello students and welcome back to Diksha Vedantu Foundation channel, and you are watching 99% in 99 days. Today is day 25. Today is the time for a physics class. Okay, so what all we are going to discuss today? We are going to discuss the chapter Human Eye and Colorful World, and today we are only going to discuss about human eye, its defect, etc. So without any delay, let's see what all is in store for today's class. So first of all, human eye is basically can be classified into two parts of the chapter. Power of accommodation is one part and another part is defect of vision. Okay, so we will discuss everything about these two. Also, what are all the defects of vision? Myopia, then we have hypermetropia and presbyopia. We will discuss everything in today's lecture. Okay, these the content for today's lecture, and what all is there in our next class. Tomorrow's class we will discuss about the natural phenomena, mainly dispersion of white light. Then we will discuss atmospheric refraction, and then we will discuss in atmospheric refraction there are two main parts, which is twinkling of stars and then advanced sunrise and delayed sunset. So these are the portions that we are going to discuss. Also we have scattering of light. In scattering of light, Tyndall effect and blue sky of our sky. Why is the sky is blue? So everything we are going to discuss tomorrow's class. Today we will focus mainly on human eye section. Okay, so first let us look into a beautiful picture of our eye. Okay, I know you have seen this kind of diagram. Okay, let us understand briefly about it. Okay, so there are different parts, and the main part, that the color of the eye, that we say that the black portion or gray portion for some people. Okay, some people may have blue eyes as well. If you have any other color than black or gray, don't forget to mention that in the comment below, right? So because I have not seen many people with different eye colors unless and until they are using artificial lenses. Right now, black and gray are the most common colors. Now what are all these? So here the main part of this is this eye lens. Okay, this is the lens. This is basically a convex lens. Okay, and here we have a muscle called ciliary muscle, which contract or expands based on our need, and the same eye which helps us to see object which is close to our eye, okay, also helps us to see something which is very far away from us. Okay, so everything is controlled by this same single lens. Okay, one lens, generally we know that for a normal lens that we have learned in our previous chapter, they have a fixed focal length, right? But our eye lens has a variable focal length. It can vary its focal length by some distance. Okay, it's very far off. We will see how far we can see using our eye. Okay, and there are some coverings to our eye. Okay, pupil, iris, cornea. You have all learned this in your bio class perhaps, but our main focus is in this. This is called our crystalline lens, and here we have the retina. Retina is basically a big screen, like when you project a movie in a theater, the screen is what you see the movie, right, where the everything is projected. Similarly, here the things that you are seeing, that is projected inside this retina, and there we have optic nerve. That optic nerve carries this information to our brain, and we interpret if you are whatever you are seeing. For example, you are seeing me right now, right? So your eyes are getting light from this device that from which you are watching, and then light is basically falling on your retina, and then your brain is interpreting. Okay, Soumik Sir is teaching your physics class in today's class, right? So now let's look into our main thing, how our eye can form an image. Here we have taken a leaf. Okay, and this is the lens. Okay, this is the pupil. So now this light ray traveling from this leaf actually travels in this direction. okay, and this lens is basically focusing it, and we are somehow seeing this leaf here, but the leaf is actually inverted. The image of the leaf that is falling on the retina is inverted, and here we have a lot of nerves. That nerve is actually capturing that image, and then through this optical fiber, okay, optical nerve, they are basically transferred to our brain. Okay, and our brain is basically interpreting the image, and there is a time taken. So when you see some object, okay, there is a time for which your brain can process this image. This is basically one of 30th second. So that's why that much time is required to process one image by your brain. Also our optical lobe is is behind our brain, so it takes some time for the information to reach to our brain. Right, there are different portions. Most part are covered in biology, okay, but we are basically covering only the image formation part, where we are interested how our eye can see different objects at different distances. Okay, so let's see, that is accommodation of eye. The curvature and focal length of the eye can be modified to some extent by ciliary muscles. So ciliary muscles plays a huge role, okay, and only one lens which can adapt automatically without any guidance. This is our eye. Okay, the modern technologies, they have tried to develop something in cameras, etc., but there some kind of intervention is required. Also, it is not spontaneous. It takes some time to adjust the distance, right? But in case of our eye, it is almost spontaneous. Same eye, if you are seeing some object which is very close, or if you are seeing an object which is very far, immediately your eye can accommodate. Okay, so basically this term is called accommodation. Okay, when the muscles are relaxed, the lens becomes thin and its focal length increases. So when you are relaxed, you are watching something which is very far away from you. In that case, your muscles are relaxed. Okay, normal standard position. They are not neither stretched nor extended, so they are called a relaxed position. Okay, the lens is thin and its focal length increases. This enables us to see distant objects clearly. That's why when we see distant objects, our eye feels soothingness. Okay, so that's why when we used to we were kids, we used to sit in the terrace and we used to see the sky. Okay, nowadays sky is polluted, so the sky is not clearly visible. So that's why when we visit some rural areas, some places where there are a lot of greeneries, you can see a lot of distance without any obstacles. That soothes our eye, because our eye muscles are relaxed in that case, right? So that's why when doctors suggest that if you are studying a long time, or if you are watching something which is very close to your eye, after an hour, try to stretch your eyes, try to look objects which are very far from your eyes, so that your muscles relaxed and your eye is safe, right? These are the few things that you have to remember. Now, when you are looking at objects closer to the eye, the ciliary muscles contract and making the eye lens thicker. So when you are reading a book, you are playing a game in your mobile phone, or you are watching my video in your mobile phone, your ciliary muscles contract, making your eye lens thicker. Okay, consequently the focal length of the eye lens decreases. So in that case, what happens? The focal length of your eye lens decreases, so that allows you to see objects which is very close to you. This enables us to see nearby objects clearly. Okay, the ability of the eye lens to adjust its focal length is called accommodation. So if they ask you what is accommodation, so you have to mention that the adjustment of the focal length of the eye based on the distance is called accommodation of eye. So I can accommodate distance. Where you are watching, based on the distance of the object, your eye can adjust its focal length, and that's how you can see the objects which is close to you or which is very far from you. Okay, that is the accommodation of eye. However, the focal length of the eye lens cannot be decreased below a certain minimum limit. So when you are observing objects, focal length cannot be decreased. So for seeing object which is very far, your focal length is maximum. as the object is coming closer to your eye, in this case your lens is adjusting the focal length, because why this is necessary. First let us understand why the adjustment of the focal length of eye is necessary. So if you see this image, here we have seen that the distance between retina and the eye lens is fixed. Okay, the distance between the lens and the screen, basically you can say this is the screen. Okay, natural screen. So this distance is fixed, and no matter where the object is, object can be close to the eye, object can be far from the eye, no matter where the object is, the image always has to form on the retina for you to be able to see it. Clear? That is the main purpose. No matter where the object is, okay, based on the focal length, we know that based on the focal length, if the object is somewhere, light focuses on the focus, right? If the object is at infinity, light focuses at the exactly at the focus. So when the object is at infinity, okay, where your image is being formed, that is your natural focal length. That is the natural focal length of your lens when the object is an infinity. That is, you are watching objects which are very far away, moon, stars, okay, at night, or very distant lighthouse that you are seeing from some remote areas. So those are basically when you are watching some objects which is very far, your eye is in their natural state, and that is the natural focal length. Now as you are coming close to your eye, the object is coming close to your eye, okay, this focal length has to adjust, because this distance cannot change. Your eye cannot change the distance between this lens and the retina. But if you adjust the focal length such that the image is always formed on the retina, okay, then your eye can always see objects, right? Now, so basically this is why we need the accommodation of eye, because the distance between our retina and lens is fixed, right? Also, no matter how close, your eye can accommodate distances, it cannot go below certain value. Okay, there is a maximum limit. Okay, sorry, there is a minimum limit. Now what is the minimum limit? The focal length of the eye lens cannot be decreased below a certain limit. Okay, thus to see an object comfortably and distinctly, you must hold an object about 25 centimeter from the eyes. Okay, so this is the minimum distance from which you should keep your objects which is close to your eye. Okay, so for while reading a book, the book should be held at least 25 centimeter from your eye. Okay, 25 centimeter means this you can consider 15 centimeter, like that. Okay, 1.5 finger. Okay, like this, 2 finger maximum up to. Okay, that distance you should keep. You can try it at your home. You can take a book, try to bring it closer to your eye, and you can see how far you can read. After some time, your eyes cannot distinguish the letters. Okay, so that is the minimum distance of distinction. We will talk about that. At which objects cannot be seen most distinctly without strain. Your eyes will feel strain if you are reading objects from very close distance. Okay, your eye will feel the strain, and after some time your eye will start paining, right? So don't read or don't write on something which is very close to your eye. Maintain this 25 centimeter distance minimum, that is safe distance. Okay, you can read anything which is up to 25 centimeter. If it is closer than 25 centimeter, it will strain your eyes, and slowly you will lose the accommodating power. Okay, this is called the least distance, very important term. This is called the least distance of distinct vision. Okay, least distance of distinct vision. Anything closer than that, you cannot see it without making your eye strained. Okay, and if you keep on straining your eye, after some time quickly your eye will lose the power of accommodation. So be careful. It is also called the near point of the eye. This is called near point. This is also an important term. For a young adult, okay, with normal vision, the near point is about 25 centimeter. Okay, 25 centimeter. And the far point is infinity. So what is the meaning of that? The meaning of that is, thus a normal human can see an object between 25 centimeter up to infinity. So anything kept between 25 centimeter and at infinity, you can see using your normal eye. Okay, and one more thing is that you cannot see multiple objects unless and until you are focusing one of them. If there are different distances, different locations, you can see one object at a time. You cannot focus all of them using your eye. Why? Because your eye can focus only that object. So you have the command in your brain. You can command your eye, okay, look at only at this object. Okay, you don't want to look into the other objects. Okay, your eye cannot do it automatically. Your brain has to send some signal. Okay, look into Soumik Sir's video right now. So they are controlling your brain, but after some time, if you feel bored, you will look into some other direction. Okay, and your brain will say, look into that picture. Right, like that your eye can accommodate distant objects which are at different distances. Okay, so focus is very important when you are studying anything. Next part, if you are not focused in your studies, like you are getting distracted during our lecture, then worry not. Diksha is presenting a very interesting thing which is called DSAT, or Diksha Scholastic Aptitude Test, which will tell you what are your strengths, where you should focus in your future. Okay, you should not lose your focus. You should not try multiple things, but you should know, okay, I am comfortable for this and I should focus on this thing only. As I said, you cannot focus multiple things at a time. Similarly, your career is also like that. You cannot focus on multiple things at a time, but you can test yourself and you should know what are your strong points. Based on that, you can choose a good career option. So how to do that? First of all, you have to register in our portal. The link is given in the description. Once you register, okay, you can attend one class. That will be 1 hour lecture. Only one class will be there. Okay, and that will be on a Sunday. So no tension. You can attend this class easily. Once the class is over, whatever the class was about, the teacher will clear any doubts that you might have. Once the doubt clearing is done, then based on that particular lecture, there will be a 1 hour test. Okay, 1 hour test. Once the test is over, based on your test results, like how much you can remember, how much can you understand, so based on different levels of understanding, okay, there will be a one-on-one counseling for you. Okay, once the counseling is over, you should know what should be your area of expertise, where should you focus. Either you should go for JEE in future, that is joint entrance for engineering, or a NEET, that is if you want to become a doctor, or KSET, again an engineering choice for students in Karnataka. So you can based on the result test results, you can choose what should be the best for your career. Right, now without any delay, let's not lose our focus. Stay here with me, because we are going to discuss another very important concept, that is defects of vision. Sometimes the eye may gradually lose its power of accommodation. In such conditions, the person cannot see the objects distinctly and comfortably. Okay, the vision comes blurred due to the refractive defects of the eye. So slowly, people like me, like I am wearing a glasses because my eye cannot accommodate objects. Okay, naturally, so I had to wear something to correct that vision. We will discuss that in a while. So what is that? Our eye cannot accommodate naturally. Okay, so natural accommodation power is lost due to various reasons. There can be different kinds of reasons. We will discuss some of the reasons. Okay, here are the main 3 common refractive defects. They are called refractive defects because eyes cannot focus the light. Okay, there are many other types of defects of the eye as well. Some defects can make you blind as well, but we are not going to discuss about all the defects. Our major point of discussion is refractive defects, when your eye lens naturally cannot focus. Okay, so myopia or nearsightedness, that is called myopia. First defect is myopia, also called nearsightedness. Second defect is hypermetropia, also called farsightedness. Second is presbyopia. Third is presbyopia. We are going to discuss one by one about them. First, we will discuss about myopia or nearsightedness. Now, don't get fooled by this name. Okay, myopia or nearsightedness. Nearsightedness is nothing to do about seeing objects which is closer. Okay, so let's see what is it. A person with myopia can see nearby objects clearly, okay, but cannot see distant objects distinctly. So that means people can see objects which is close to them, anything between 25 centimeter up to certain distance, but after that it cannot see anything beyond clearly. Okay, for example, I cannot see objects which is very far from me. Okay, that's why I need glasses. Now there are different reason. First of all, the person with this defect has a far point nearer than infinity. That means normally far point is at infinity. I already told you that normal person can see objects between 25 centimeter up to infinity, but if somehow your eye cannot detect infinity as their far point, a far point come forward, okay, then this defect can occur. Such person may see clearly up to a distance of few meters, up to a few meters, 1 meter, 2 meter, they can see clearly, but in a myopic eye, the image of the distant object is formed in front of the retina. Okay, so the image is formed in front of the retina. Okay, it cannot reach the retina. Okay, the focal length is disturbed, focal length is changed, so that's why it cannot reach the retina anymore. That's why it is called nearsightedness. Okay, also nearsightedness means that you can see objects which is near to you, you cannot see objects which is far from you. That is one of the meaning of nearsightedness. Nearsightedness means you can see objects near, you cannot see objects which is far. That's why it is called myopia. Okay, now what are the possible causes for this? Let us discuss the causes for this. Excessive curvature of the eye lens. Okay, this is a defect that can cause due to various things. For example, if you continuously read objects which is close to your eye, or if you cry a lot when you are a child, or due to some birth defect which is very common. Okay, and if you study in low light situation, that is also a possible causes. Okay, and because of that excessive curvature of the eye lens, your eye is now more curved. Normally we have seen the eye is like a circle or sphere basically, but after some torture to your eye, if somehow your eye becomes a ellipsoid, okay, like an ellipse, like an egg. Okay, so basically your eye was supposed to be up to here, but so your lens is basically focusing the light here, but your eye, because of the defects, all the torture that you have done to your eye, okay, your eye lens is now extended and your muscles, everything is here. Okay, so your eye cannot see whatever objects that is very distant objects, right, because they are all getting focused here, and because of the shape change of your eye, you cannot see the object clearly. Okay, elongation of eyeball, the eyeball itself can elongate it, which is also very common. Eyeball itself very elongated and you cannot see the sorry, this is the part, so my mistake. Elongation of the eyeball is the second part. This is the elongation of the second part. Excessive curvature of the eye lens is this. So your eye becomes, so there are two possibilities. One is your eye is already elongated. Okay, this is the elongation part. Normal your human eye lens is like this. Okay, but if somehow it is elongated, its curvature is more, excessive curvature, okay, your eye is now thicker somehow. Because of some defect of your eye, if the eye lens becomes thicker, then in that case you cannot see distant objects clearly. Okay, these are the two reasons. Next is let's see the diagram. So normal human eye can see objects at very far, but this person cannot see objects beyond this point O. Okay, because his far point is shifted here. Okay, its far point from infinity shifted to some point, and up to this point only he can see clearly. As you can see, if the object is here, then he can see it here like this. But to make this thing correctly, this is this is the far point of the myopic eye, this is the myopic eye. For objects which are very far away, what is happening? They are getting focused even before they are reaching the retina. Okay, so this is the defective eye. So if they ask you draw a diagram for myopic eye, you have to draw this diagram. Okay, this is the most important diagram, myopic eye. Okay, and how to correct it? To correct it, we will use a concave lens. Okay, concave lens is used to correct myopic eye, and generally we know that concave lens focal length is negative, so the power is negative. So if you are wearing glasses with negative power, that means you have a myopic eye, right? If your power, if anyone is wearing any glasses, ask them what is the power of your glass. Okay, if they say -1, -2, that means they have myopic eye, they cannot see objects beyond certain distance. Okay, so this is the concave lens which is used to correct this defect. Now after using this lens, this point is adjusted such a way that even the objects which is very far, they can also focus inside the retina, and you can see any objects between infinity up to 25 centimeter as usual, right? Next point is hypermetropia or farsightedness. A person with hypermetropia can see objects clearly but cannot see nearby objects distinctly. So farsightedness means you can see objects which is far clearly, but whatever is closer to your eye, you cannot see them. Okay, far objects is clearly visible, but closer objects is not clearly visible. The near point of the person is further away from the normal near point, that is 25 centimeter. Okay, normal near point is 25 centimeter, but somehow the near point is now shifted to 30 centimeter or 50 centimeter because of some reason. Okay, then the light rays formed by close by objects are focused at a point behind the retina. Okay, in this case what is happening, your eyeball is shortened, so that your rays are actually crossing the retina and they are focused behind the retina, so you cannot see them clearly. Okay, the focal length of the eye lens is too long. Okay, focal length has increased somehow, or the eyeball has become too small. So eyeball has become too small, so that you cannot see the objects clearly. Okay, focal length, either focal length is too long, that means now the lens is thinner. Okay, thin lens has longer focal length, so they have a longer focal length. Either your thin lens has become thinner or your eyeball has become shorter. So for example, in the previous case I gave you the example of egg. Okay, normal eye, this is, if this is your eye, okay, normal eye does not look like this. We draw, when drawing this, we draw generally like this, but that is for a two-dimensional figure, right? So this is like when you are drawing like this, right? I am not very good at drawing, so please pardon my drawing. But when you are you are suffering from hypermetropia, your eye becomes like something like this. Okay, your eye becomes like this. Normal eye is like this. This is the normal eye, but your eye somehow becomes shorter. Okay, and anything which is supposed to be converging on the retina, close objects, what is happening? Instead of focusing on the actual retina, it is getting focused behind the retina. Okay, this is the retina of a normal person, but you cannot see that. That's why this kind of defection occurs. Now correction, this defect can be corrected by using a convex lens of appropriate power. So in case of myopia, concave lens; in case of hypermetropia, it is convex lens. Okay, both lenses are opposite. Now let's look into the diagram. So this is the diagram. Normal person can see up to this distance, but somehow this person cannot see the closer objects. They can see objects which is from further point, okay, from N. Now if the object is exactly kept at the near point, then the image is getting formed behind the retina. To correct this, you have to use a convex lens. Now after using the convex lens, the rays are getting formed like this, and again you are seeing the image in the retina. Okay, so as you know, convex lens has a plus power. If anyone has plus power in their eye, that means they are suffering from hypermetropia. Okay, hypermetropia is very common. One of the common reason for older people cannot see objects. The reason is different, that's why the name is different, but the main problem of an older person is that they cannot see closer objects. Okay, so they need a convex lens as well. If they have a plus power, that means they are suffering from hypermetropia. Hypermetropia is less common. It is common amongst children, okay, below certain age, and after with gradual aging, okay, this becomes normal. They do not need plus power. Okay, there are many students, I know if someone of you are watching as well, that they had glasses when they were kids, but slowly as they grew up, they don't need the glasses, okay, because they had the problem of farsightedness or hypermetropia. But with the aging, okay, your eye balls are now perfect, and you can see the close objects as well. But myopia is more common, okay, and it does not go away with aging. Okay, it generally increases. Your eye generally requires higher and higher power slowly over age, right? Because your eyes are not fixed, they are changing the shape. Okay, and because of that, myopia once occurs generally does not go away without any surgery. Okay, you need a surgical solution to remove that kind of defect. But hypermetropia is less common in normal adults, and even if they have it, they require glasses, but after some time this problem goes away, unless they have a permanent eye defect due to some genetical problem or some hereditary issue. Okay, there are many people, they suffer from this disease as well. Now let's look into the third part of eye defect, that is presbyopia. So as I was saying, the power of accommodation of the eye usually decreases with the aging. So as you grow older, okay, not of my age or of your age, definitely you are thinking that from your age if you reach my age. No, when you grow older means maybe 50 plus, 60, like that, okay, very old, like your grandfather, grandparent, okay. So as you grow older, your eye loses its natural accommodating power, because as you grow older, our muscles becomes weak. Similarly, our ciliary muscles, which is responsible for the adjustment of our eye power, okay, they also becomes weak. Okay, so for most people, the near point gradually recedes away. So as we discussed in hypermetropia, same thing happens. The near point slowly goes farther and farther. So they cannot see objects which is closer to their eye. Okay, they find it difficult to see nearby objects comfortably and distinctively without corrective eyeglasses. This defect is called presbyopia. Presbyopia is not due to any kind of defects of the eye or any kind of defects of the lens. It occurs mainly because of the defects, weakening of the ciliary muscle. So you have to understand, if the ciliary muscles weakens, the defect is called presbyopia. If something is happening to a healthy person, young person, then myopia or hypermetropia is the name. Okay, if it's something is happening in an old person, the name is presbyopia. Okay, not like that they cannot have hypermetropia or myopia, but most older persons, they suffer from the weakening of the ciliary muscles, and they naturally require glasses, and that's why this name is separate, and that name is given to as presbyopia. Okay, the gradual weakening of the ciliary muscles and diminishing flexibility of the eye lens gives rise to the presbyopia. This is caused due to age. Obviously the cause for this is age. Also far point is also reduced with age. To correct this, we need a lens called bifocal lens. So for some person, okay, they can not only see closer objects, they can also not see distant objects as well. So you can see the objects between the eye becomes very restricted. Okay, they can only see distant objects which is somewhat between the near point and far point. So that's why they cannot see clearly the distant objects, they cannot see clearly the closer objects, so they suffer from mental agony. Okay, nowadays, previously when in ancient days, people used to lose many hopes during that time. Their sensitivity, other sensitivity also becomes weak. Okay, they cannot hear properly, they cannot see properly. So that was one of the problematic things for older people. Now science has brought us a new thing called bifocal lens. Not super new, but it is also in the journey of science, it's not very old. Okay, so bifocal lens is a type of lens which is used to correct both near of the distance as well as far distance. Okay, And how does it work? Basically your normal lens, which is you are wearing glass, okay, they have two kind of glasses. This is the longer main portion is used for your far-sighted nearsightedness, that is this portion is used for myopia, or let me not say the myopia term, let me use the term, this portion is concave lens, okay, and this portion is convex lens. Okay, tell me if you have seen such kind of lenses. Okay, basically the lens has two parts. One is here, a small portion in near your nose. Okay, that is convex lens, which is used to read closer objects, and normal lens, which is used to see objects which is further from your eye. We actually watch objects which is further from our eye more often than which is closer to our eye, right? Only while reading something we will need the closer portion, right? So this is called a bifocal lens. Bifocal lens means they have two types of lenses. One is a convex lens, one is a concave lens, all together in single lens. That's why it is called bifocal lens. Now let's see one example problem. A person needs a lens of power minus 4.5D for correction her vision. Okay, what kind of defect in the vision is she suffering from? So obviously the power is negative, that means it's a concave lens. Concave lens means the defect is definitely myopia. Okay, myopia is the defect which is occurring when you are not able to see objects which is very far. That's why she needs a lens of minus power. What is the focal length of the corrective lens? Focal length, we know that focal length, relationship between focal length and power of the lens is f is equal to 1 by p, or minus 4.5. But this is in meters. To convert it into centimeters, we will use 100. Okay, and it will be approximately minus 25. Okay, 25 centimeter is the focal length of the lens. Okay, what is the nature of the corrective lens? Nature of the corrective lens, as we have discussed, the power is negative, so it is a concave lens. Okay, so the question number 1 and question number C are related, because both cases we are determining it is a myopia based on the fact that this is a concave lens, because the power is negative, and the second part is independent. It is basically somewhat related to your light chapter, but this is a complex chapter. It is a question from your previous year board exam, one of the papers. This question was there, so that's why this is an important question. Okay, now let's take two homeworks. First homework is this: study the diagram given below and answer the questions that follow. Okay, so this is the diagram, and what are the questions? Name the defect of vision depicted in this diagram, starting the part of the eye responsible for this condition, stating the part of the eye which is responsible for this condition. List two causes of this defect. Okay, name the type of the lens used to correct this type of defect and state its role in this case. So this is a interesting question. First of all, you have to identify what type of defect it is. Secondly, two cause of this defect, and thirdly, what type of lenses you will use and why you will use such lenses. Okay, so these are the three things that you have to answer from this question. And another homework: a student sitting at the back of the classroom cannot read clearly the letters written on the backboard. What advice will a doctor give to her? Draw a ray diagram for the correction of this defect. So correction diagram for this defect, very easy question. Try to practice these two questions. Okay, if I get a chance, I will discuss these two homeworks. And if you liked our video, don't forget to share it with your friends. Also, if you are still confused about your future after watching the entire video, then obviously Diksha is presenting DSAT, that is Diksha Scholastic Aptitude Test. You can register register in the link given below, okay, where you have to input your name, email, phone number, and board, class and board of your child. You can ask your parents to fill this form for you. And what will be there for the class? First of all, there will be a 1 hour lecture. Okay, during that lecture, teacher will teach you some concepts. Okay, and after the concept is being taught, there if you have any doubts, you will have a lot of clarifications. Everything will be cleared by the teacher. Once everything is cleared, you will be asked to take a test based on that particular lecture. Once the test is over, based on your test results, a counselor will guide you what suits you best. Okay, whether should you think about your career. You want to become a doctor, but your aptitude is not enough to become a doctor. Or if you think, what I will do, I am going to do nothing in my future, I will just do and sell pakora. But after taking the test, you realized you are very much suitable to become a doctor. Okay, or you can easily become an engineer, or you can become an architect. Whatever is your dream is, that dream, realize this dream by taking this easy test that is called Diksha Scholastic Aptitude Test. I also request any parents watching, you can enroll your child here so that your child gets the best future. Also share this information and our channel with your friends, families, so that we can meet in a future video. Till then, bye.